Jennifer, if you can hear me right now, can you confirm that you are able to hear our audio for me? Thank you so much. All right. Hello, everyone. Apologies for the slightly rocky start today. Had some trouble getting everything set up this afternoon. Some slight technical difficulties. Hope you are able to see us here now. Looks like we are getting some okay audio going. So just Jennifer, if you could confirm that for me. Thank you so much.
Yeah, you can hear us.
Okay, good. Woo, sorry about that, everybody.
Oh, hi.
Well, welcome to Sky Observers Hangout. Glad that you could join us today. Glad that we have finally made it here and that we have everything working for us. Fortunately, the telescope's doing great. The sky is doing great. Those are going to be the most important things for us today. So as always, Sky Observers Hangout is a place for us to gather together to nerd out about the sky. Our goal is to give you some practical tips to observe because this night, tonight is a great night to take a look up, whether you have a telescope like us or whether you're just looking with the naked eye. Tonight, we are taking a look at the Venus and Jupiter conjunction. So we've got a couple of folks helping out in the chat, which you are certainly familiar with at this point. Jennifer is our chat moderator tonight. She's the name that you see as Adler Planetarium there in the chat. Thank you so much for entertaining the people while we were away, Jennifer. We also have.
But come on, guys, we got to talk about this just for a second. Can you see your background right here?
That's true. We've got
thing
a very beautiful view of the city behind us to make up for the late start here. We've also got Geza joining us in the chat. He's got the little blue wrench next to his name. He's one of our astronomer friends, helping us to answer any and all of the questions that you have tonight. So please make sure to leave all of the questions that you have in the chat today, for sure. Now, the first question that we have for all of you to make sure that our chat's working well is, where are you all joining us from today? Let us know where you're joining us from. We'd love to hear all about that. And while you let us know that, I'm going to go ahead and get our telescope view set up so that we can take a look at this conjunction tonight.
Yeah, why don't we do that? So
absolutely.
We're going to switch our view.
All right. So here you can see our live telescope view that we have going. We've got a couple of bright points there in view. Those are, of course, Venus and Jupiter that we're taking a look at. Now, Michelle, can you describe a little bit like what we are taking a look at here tonight?
Yep. So we are seeing Venus and Jupiter through our telescope, which is just off to my right here. So if you see me going off camera, that's where I'm going. So the telescope is right here. Got a camera hooked up to it. We've got Venus, which is the brighter the object on the bottom of the view, and then Jupiter is the one at the top. What I can also do is do a little zoom in, an electronic zoom. So why don't I do that? You may see the view shake because that is my literal hand touching the literal telescope. So forgive the shakiness, but that's just me actually touching the telescope. So.
Yeah, so today we've got, this is a little bit different than what we often have out in the dome where, you know, the telescope is big and tracking. Today we're looking out to the west. And so the dome doesn't see quite well in that direction. We got a big planetarium in the way. So we've got a separate telescope hooked up today that we're using. We can see Michelle did a little bit of a zoom in there for us. Which one of the two planets are we looking at right now?
Oh, that is definitely Jupiter. And you can see 3 of Jupiter's moons.
Yeah, I love seeing those 3 moons. So just off to the sort of the right of the image, you can see those moons there. There you go. That extra exposure really helps there. Now these things are moving across the sky pretty quickly. So we'll have Michelle disappearing in and out of view as she goes and adjusts things for us.
All right. So if you want to know where you can go out and see this conjunction right this very second, if you are in the central time zone and the sun has set for you, go outside, face west, look up. You're going to see 2 bright things. Those are the only 2 bright things you will be able to see pretty much.
Exactly.
That's Venus.
That's a good hint. That's a good tip.
Go outside, face west, look up. If you're in the Eastern time zone, they're probably pretty low in the sky right now. So go outside, face, I said east, west. Go outside, face west, don't look quite as high in the sky. If you're in the mountain time zone, go outside, well, after sunset, and you'll be able to see them. If you're in the Pacific time zone, you're going to have to wait till after sunset. So I'm going to adjust
all kinds of great tips there.
I'm going to adjust the view a little bit.
Now, one thing that's really lucky about this tonight is, oftentimes when we're looking west towards the sunset, right, it can be pretty tough to see a lot of objects. If you look in the western sky right now, you won't see too much. Fortunately, Venus and Jupiter are two of the brightest things in the night sky. So we're actually able to see them really totally clearly with the naked eye. You can see them hanging up there almost straight west right now. They're about 25 degrees up at the moment. So just about a little more than 2 fists held out at arm's length. And you'll see them real close together, about the width of a full moon tonight, half a degree apart.
Let's do a little demo of that. I'm going to back up a little bit because we're actually here together at the same time. We're not doing this from separate locations. This is actually kind of cool. So what you want to do to get 25 degrees up, how far is that? Take your fist. This is the demonstration portion where you can take part in this, but I won't see you. So don't worry, but you can see me. So I want you to go and stick your fists out at arm's length from the bottom of your fist to the top. That is 10 degrees of sky. Put another fist on top of that. That is 20 degrees of sky. Put another fist on top of that. That's about 30 degrees of sky. So there you go. Half a fist, 5 degrees. One thumb held out at arm's length, 2 degrees. And so what I want you to do, if you can see Venus and Jupiter right now, tell us in the chat if you can see it. Then you will see that Venus and Jupiter are less than a thumb's width apart right now.
I like that when it's connecting it back to, something that's a nice close reference point, right? We all know how big our thumb looks, right? So even closer together than that. Now, I wanted to shout out a couple of locations that folks are joining from. I saw a few different places in the chat, lots of Chicago, and we are lucky for everybody here in Chicago today. You can get a good view. All you need is a good view to the west, make sure there's not a bunch of buildings blocking the way, though they're still pretty high in the sky at this point. They'll be getting lower towards the end of the night. We've also got Mexico City, Ohio, Missouri, Boston, Wisconsin, all kinds of places. Yeah.
Thanks for joining us. This is fantastic. Wonderful. Thank you. And thank you for sticking with us for our little technical glitch right there.
Yeah, absolutely. Thank you for hanging around for those minutes when we started a little later.
But this is not just us talking at you. This is your opportunity to ask questions. I know Gaze is in there answering questions for you. But we had a great question that we got fed to us from Jennifer. Will the planets collide?
Oh, what a great question. And I think this really helps get to kind of the root of what a conjunction is, right? So we're taking a look at this. We can see that they're very close together, but a conjunction is much more about an observing sort of event rather than something in particular that is happening out in space, right? So we can see that these are really close together. Does that necessarily mean that Venus and Jupiter are really close together in space?
No, actually, they're pretty far apart. So Venus is interior to the Earth's orbit. Jupiter is exterior to the Earth's orbit. So Venus is closer to the sun. Jupiter is a lot farther from the sun. So I believe you have a little slide where we can show folks.
Yeah, absolutely. So we can take a look here. And what we can see here is actually an image of the current locations of a few different planets in our orbit right now. And if you go to the next slide, you'll see you can get a pretty good idea of why we see a conjunction tonight. From the perspective of the Earth, you can see that line going straight through, does a really good job of cutting right through Venus and Jupiter. Now you can see Venus and Jupiter not particularly close together in the sky, right, or in space right now. But if we go back to our live sky view, really nice and close together for us here on Earth.
So Hunter, how far apart are these two planets right this very second?
Ooh, right this very second.
Approximately.
It was just a little bit over, 400 million miles? Is that right?
Yeah, about 410 million miles apart. So our long-winded answer to will they collide? No.
And then, we could also think about this from the perspective of the observer. Will they look like they'll collide in the night sky? Now, this right now is actually about the closest that they'll get. Over the coming, next week, they'll still look pretty close together in the night sky each night. So even if you aren't able to take a look tonight, there will still be lots more opportunities to go outside and look at Venus and Jupiter together in the night sky. But this is the closest that they will be appearing here in this month, that half a degree mark.
Yep. And so I just adjusted the view through the telescope. I had to overexpose Jupiter in order to get its 3 of its moons. And you're seeing it zipping out of the view pretty quick. So I have to adjust again.
Yeah, when we're zoomed in this close, we've got a real small field of view there that we see on Jupiter.
And so when you overexpose Jupiter, then you can see the moons. If I underexpose the moons, you can see Jupiter a little bit better. So let me do that.
So thank you, Michelle, for all your camera wizardry tonight.
It's called telescope gymnastics. And
Now,
go back out.
one thing that we will notice, when we're getting that zoomed in view, not only is the camera limited in what it's able to do, but since these are a little bit lower in the sky, that does affect our sort of viewing conditions. Can you talk about how them being a little lower in the sky affects how we see them through the telescope?
Absolutely. So what we're doing is we're looking through more air. So the lower these objects get in the sky, the more air you're looking through. And so that means the view might be a little more shimmery. It might be a little dimmer. So you probably noticed when we did that electronic zoom just now, Jupiter probably looked a little jiggly. So it definitely was. And the view will just kind of jiggle around even more as Jupiter gets lower in the sky, as they both get lower in the sky. So that's not really anything we can do anything about. It just is the way it is when you look through that much air. And so it'll only get worse as they get lower. But what we want you to do is go outside and look at this for yourself. Those of you in the Chicago area, go outside right now. They're there. We can see them. So definitely check this out for yourself.
Now, one note I want to make, if you're going out to take a look at these two planets right now in the night sky with the naked eye, and this relates to a question that we actually got in the chat. Why does the telescope show them vertical? So if you were to go out in the night sky right now, they actually wouldn't look exactly how we're seeing them through this telescope view right now. They would look almost right next to each other in the night sky. So what is it that's causing that to happen, Michelle?
My camera. My camera, the way it's attached to the telescope, it's turned. So that affects it. But also the telescope will flip the images as well. This is what you can't see is a refracting telescope. I'm wondering if there's a way to show people. Well, I don't know if we can, but anyway, the telescope is over here. You'll have to trust me. And so a refractor or basically any telescope is going to flip your image upside down. So we already have that going for us. But in addition, the camera, the way it's attached to the telescope, it's turned. So that's why we're seeing it at a different orientation than how you're seeing them in the sky.
Yep. And this is something that's really common with telescopes, right? Lenses, mirrors, they often flip images around. But when we're looking at space, who cares? There's no upside down in space, right? It might look a little bit different than it appears to the naked eye, but doesn't affect our viewing too much.
By the way, Hunter, did we describe where exactly we are right now? We didn't.
Oh, that's a great question. I don't think we did.
We just started the show because we're like, oh my God, it actually works. We got our technical glitch worked out.
Exactly.
So we didn't actually tell you where we are. We are on the north side of the Adler building. So we have an upper terrace on the north side, and that's where we are. So we probably have the literal best view in the city this very second.
So.
You'll have to trust us.
You can kind of see it behind us, a little bit of the reflection. Now that it's getting darker outside, you can't see the reflection so well.
Cow, is this city beautiful?
It is, yeah.
So,
as is inside the solarium, our solar system gallery. That's what's sitting right behind us.
The Adler Planetarium right behind us.
Yeah, so
we've got folks down below us who are looking through small telescopes. So we've got some small scopes out, folks enjoying all that right this very second. So we have a lot going on here at the Adler.
Yes, absolutely a blast having so much observing going on for this. It's a beautiful night here in Chicago. Yep. Not too chilly, nice and still, not too windy, beautiful clear skies. I mean, can't really ask for much better than that. Una, we've got a couple of questions asking, is Venus the brighter one?
Yes, that's an easy one. Venus is the brighter one. Yes, it's very reflective. It's covered in clouds. So those clouds reflect a lot of light from the sun, and Venus just isn't all that far away.
Yeah, it's pretty close relative to, space numbers, right?
In the grand scheme of things. And so, yes, if you're looking at them right now, Venus is the brighter one. Jupiter is the slightly dimmer one. And then over the next few days, if it's cloudy where you are, or you're not able to go outside right now, then they'll be farther apart over the next few days. So about a degree apart tomorrow, about 2 degrees apart the next day. So you'll still see them, but they just won't be quite as close as they are tonight.
Yeah, that's a great thing to mention. This is not a one day only event. Sure, they are as close as they'll be today, but you'll still be able to spot Venus and Jupiter beautiful up in the sky there. Lots more days this week. Now, some other fun questions that we have. One person in the chat thinks that Jupiter will eat Venus. Oh my goodness, they are pretty close. Jupiter is much bigger than Venus is. But you know what's funny is actually a lot of the articles that I've seen have said that they were kissing tonight.
Aww.
So maybe that's a little sweeter than eating each other, right?
Yes.
I like that description of it.
That's good. Although you may have just invented a new science fiction movie.
Definitely some science fiction there. Ooh, another good question here from the chat is, why do they look so close when the orbits are so far apart? So that's such a good question. And we had mentioned how it's really about the perspective that we get from Earth.
Yeah,
so this image here does a good job of showing that, seeing the line from the Earth that goes through Venus and Jupiter, even though they're far apart. And a good way to think about this is maybe if you went outside to the sidewalk, right? And you can see a street light down the block. Well, you could hold your thumb up right next to the streetlight and they'd look really close to each other from where you're standing. But you know, of course, the thumb's really close to you and the streetlight's all the way down the block. They're not actually close together, but it's all about perspective, right? And this is all about from our perspective here on Earth.
Yeah.
And so from here today, we've got a beautiful view of the two of them.
Sure do. All right. More questions.
Yeah, absolutely. Feel free to ask in the chat if you have any more questions for us. One other thing that I wanted to mention that I think is so fun tonight, you know, with these two objects being some of the brighter objects in the sky, they were also some of the first observed objects. Really early observations were of planets like this one. And it's fun looking at these two because these were so influential in that early astronomy. So the first documented telescope observings were by a man named Galileo Galilei. You may be familiar with him. And that was all the way back in like 1609, 1610 that he was making these observations. And looking at Jupiter and Venus was actually really, really important for him. He made some really big discoveries by looking at those. Not only was it the first time that somebody was able to resolve these planets as something similar to Earth, right? A disk rather than a little dot of a star like everything else that we see in the sky. But they were also really essential in knowing, you know, getting this better idea that maybe the Earth wasn't the center of everything. You know, there were some ideas that maybe the sun was the center of the solar system before Galileo, but there wasn't a lot of proof at that point. He looked at Jupiter, and like we saw earlier, he saw moons orbiting around it. The first absolute proof that there were things that orbited other objects in space. Everything wasn't going around us, right, as we thought.
So we have a little show and tell.
Yeah, do you want to? This is kind of like our collections corner for today. Here, let me switch to just the view of our camera here. So we like to use this in a lot of our programs. And I will say this is a replica, so don't worry if you see it, you know, seeing it out here. This is a replica of Galileo's very, very first telescope. Now, this is a little bit different than the ones that we use today. Not quite as fancy as the views that we get now. But he was able to make some remarkable discoveries with this, right? So he sees those moons around Jupiter, and then he takes a look at Venus here, this other planet. And what does he notice when he looks at Venus, Michelle?
He sees phases of Venus. And so that told him that Venus, as it is moving, it is lit by the sun. But in order for Venus to experience to where we would see phases of Venus, like we see phases of the moon, Venus has to be going around the sun in order to do that. It's an interior planet. It's closer to the sun. And so that was a remarkable piece of information. Now, one thing that Galileo was really good at was letting everybody know what he found. He published his findings. He let everyone know. There were some other folks who were pointing their telescopes up at the sky, but we know his name these days because he spread his information far and wide. He wrote books and published and all that kind of fun stuff. But another thing that he saw was moons of Jupiter. Why don't we go back to our
do you
camera?
want to take a look at the moons here? Yeah, we've got the telescope camera pulled up.
So I'm gonna adjust here.
So if you were to observe Jupiter over many days, you know, at first you looked at it, maybe it could be background stars. You have no idea that it's definitely moons around it. But he would watch them over many days, which you can see they're the little points to the right of Jupiter here. We got to really up the exposure to be able to see those clearly.
Yep.
And he watched those over many days and he was seeing them change positions, but they were never leaving around Jupiter. And so he was watching their orbits over all these days, and even over the span of a few hours, you can see those positions move, right? And so he was watching those, and he determined, yeah, that really be what those must be.
Yeah.
Those have to be moons around a different body.
Yes. So he was showing that these objects orbited Jupiter and they did not orbit Earth. And so that was also a fundamental shift in thinking. Now, it wasn't immediately accepted by everybody. So yeah, Galileo published this information. It's not like everybody went, oh gosh, it's 1610. So we all now believe that the Earth goes around the sun. It still took a while for people to fully accept this information as fact. But he definitely set us on our way to be able to do that. So yes, we owe a lot to Galileo and his tiny telescope. I mean, if you take
Right.
can you see this?
Yeah.
Yes. So what he did was he was able to do this as a refractor telescope. See that? There's a lens right here. And so he had a little donut there to cover up the edges of the lens, because the edges they weren't great. The glass wasn't wonderful. Not like we have really good glass for telescope lenses right now.
Mm-hmm.
So he had to kind of cover up the edges. It also helped with getting the colors a little bit better. And so this teeny tiny little bit of glass right here is what he needed. And an eyepiece at the other end allowed him to magnify about 20 times. And so that allowed him to see craters on the moon, phases of Venus, moons of Jupiter, more stars than were visible to the naked eye. So all this information was extremely important.
Yeah, really big shift in how we were, really considering space.
Yep.
So we've got a couple of other questions in the chat.
Sure.
I'll head back to our telescope view here. So one question here is, how often does this happen? So there's different conjunctions throughout the year, but for one specifically like Venus and Jupiter, when would we expect to see this again?
I don't know when the next one is, but I know the last one was about a year ago. So.
Right. And I think on average, it's usually about once a year. It does differ a little bit.
Yeah.
And, they won't be this close together every time. It might differ in how close they'll appear. But conjunctions in general, seeing, different planets next to each other is actually quite common, right? We'll see that. We'll see that pretty frequently, at least a couple of times a year, but always exciting, especially the planets are always such a fun thing to view. And it's something that everybody can take a look at in the sky.
And you can have other kinds of conjunctions too. It isn't just a couple of planets. You can have more than two planets. You can have the moon and a planet. You can have the moon and a bright star. Basically, a conjunction is something's close to something else, or it appears close to something else in the sky. So it can be planets, the moon, bright stars. So all this can qualify as a conjunction.
Yeah, all kinds of conjunctions.
And think of it this way, a way to remember the word. And I know I'm going to date myself by saying this, but several of us remember the song Conjunction Junction, right? And so what do conjunctions do? They combine phrases and clauses, but like and those sorts of words. So they combine. Conjunction means with, bringing things together. Two planets appear with each other in the sky. There you go. Now you will never forget the word conjunction.
There we go. Yeah, that's a great way to help remember it. And one thing I want to bring up that really helps with these conjunctions happening is these planets are, and those are often the things that we use in talking about conjunctions. Planets, the moon as well, right? These big bright objects that we have in the sky. One thing to think about is how they travel across the night sky. So we can talk about this word ecliptic. Ecliptic. Can you describe a little bit about what the ecliptic line is?
Yeah, basically, actually, could you go to the prior image there? And yep, go to
absolutely.
that one. There we go. Okay, so basically you're looking at a top-down view of the solar system. So this is kind of hard to tell where the planets exactly are. So in reality, the planets, and so this is top-down view. What does it look like from the side? The planets are essentially in the same plane. Think of the planets orbiting in the same sheet of paper out there in our solar system. And so if you're viewing that sheet of paper from Earth, it's going to appear that the planets are in a particular line across the sky. And so we call that the ecliptic. And the ecliptic is defined by where you see the planets, and they don't really stray. Well, the planets, the moon, and the sun, because they don't really stray too far from that ecliptic line. So there you go.
Right. So in this picture here, we're seeing a top-down view of these orbits. But if we were to see that from the side, all of those lines would line up pretty darn closely there.
Exactly.
Yep. So that makes a big difference. You know, it makes it much more likely that we'll see the planets beside each other like we are tonight, right?
Oh, I see another interesting question. Is this telescope, meaning the one that we've got showing the two planets, is it powerful enough to show the Great Red Spot? This particular telescope, no. So what we're showing you is, and I wish there was a way I could show this to you. The only problem is if I move the camera, it won't be on us. It'll be kind of weird. But anyway, there is a telescope that's off to our right. The main lens is about this big across. This is not the observatory. So that's our big telescope. That one is big enough to see the Great Red Spot.
Absolutely.
But this one is a small scope. So it's bigger. It's bigger than the Galileo telescope, but not by a huge amount much. So it's about 4 inches across is the main lens. And that's not enough to have magnification to show the Great Red Spot. So
yeah, that's a great question.
Yeah.
So one thing that you might be able to see on here would be something like the cloud bands on Jupiter. So, you know, even through a lot of small telescopes when looking at Jupiter, you'll see a couple of stripes across it. You know, it'll be like a lighter color as the base and then a couple of darker stripes going across. That's something that you can pretty commonly see with a smaller telescope. You know, you will have issues today just because they are so low in the sky. You'll often not get as clear of detail when looking at things when they're lower in the sky like this. Whereas if you're looking straight up, not so much atmosphere to look through.
So right now I've got it pointed at Venus. So I need to move the telescope slightly. Right. And I need to adjust the exposure lower. Not sure if it's coming through. Again, the two planets are getting kind of low. So the view is not great, but what you can almost see.
Yeah, you can really get an idea of the atmosphere affecting it, right? Look at the way that the outside edge all along it is so fuzzy.
Yeah.
And jittery, right? And how much it's changing.
Exactly. We would be able to see about a little bit more than a half Venus. So let me switch back to Jupiter.
There you go. So that gave you a really good idea of which one was brighter and which one was dimmer, right? You could see Venus in the view there, but Jupiter had kind of disappeared. Yes, great note here from the chat. The left planet that you'd see, you know, if you were looking up into the sky right now, they're top and bottom in our view. But if you're looking into the sky with the naked eye, the left planet is Jupiter, the right one is Venus. You can also tell the brighter one that you can see in the sky is going to be Venus tonight. Venus is close, very reflective. It's a really bright object in the night sky.
You can almost convince yourself you see
clouds. Just barely maybe make out those cloud bands. They're tough to see there. You can almost see some darker parts. Yeah, definitely. I think that they're there. We'll see. Maybe depending on the resolution of how it's streaming for you here tonight is a good question there.
The fact that we can see this at all is kind of amazing.
That's true. That's true. Yeah, lots of cloudy days during this time of year in Chicago.
So what I'm doing is I'm adjusting simultaneously the exposure time on the camera, the position of the telescope. So that's what I keep doing when I'm going off in this direction over here. And I was adjusting the focus as well. Do that with a knob on there.
We got another question here in the chat. I'm asking if we can repeat how close they are to each other. So up in the sky, to the eye, they're about half a degree apart, the width of the full moon. And then those two planets out in space, not particularly close together right now, about 410 million miles apart right now. Great questions. Thank you so much for asking those. And please let us know if you have any other questions there in the chat.
I keep thinking that I'm trying to see clouds. But
You know, I think knowing that they're there helps you see them. If you didn't know they were there, you might have trouble. You know, if Galileo was taking a look, he might have had some difficulty seeing them.
but you can see the moon.
You can definitely see those moons right alongside. Yeah. And because of Galileo's discoveries of these moons, that is what we refer to them as today, right? The 4 Galilean moons.
Exactly. All right.
I didn't check the locations of the different moons today. I'm not sure which 3 we're looking at there.
Here, I'll look
But
it up.
Gonna look it up for us. Thank you.
Good. Second. All right. Okay, let's look up exactly which moons we're looking at. All right. Gonna look at Jupiter.
So even if you know what the 4 moons are that you can see around Jupiter, of course, because they're always changing their positions, it's tough to know which ones you're looking at any which moment. So there's some really helpful places to check that out online and look at that.
Okay, so let me go back.
Okay, yeah, here
Yep.
I can keep a hold of this if
Yep,
you want,
you
so I
got
can
that.
see that. All right. Okay, so we're gonna switch back over to that Jupiter view, pull those moons up again, and we'll see which ones we're looking at here. Got the 3 pulled up that we're looking at tonight. Now, these moons you would not be able to see with the naked eye, right? That's why it took Galileo inventing the telescope, using it for astronomy for the first time, to be able to see those objects. But with the help of, binoculars, any kind of telescope, they help. So we've got the 3 lined up there. So I'll start with the innermost one. The innermost one is Io, then Ganymede, then rounded it off is Callisto as the 3rd one.
There you go.
No, I said there were 4 Galilean moons. Where the heck's the 4th, Michelle?
Well,
there you go.
It looks like it's behind the planet. So it sometimes you might see all 4, sometimes you might see 2 or 3. Just depends on where they are in relation to the planet itself.
Yep. So we're missing one of those Galilean moons this evening, but lots of other opportunities to check out all of those. Yeah, they are there at different times. Apologies if you can hear the train noises. I can hear a train in the background. Mike might be picking that up there. Hey, that's part of doing it out in front of the Adler rather than in the dome like we usually do. So one question that you might be asking is, why did we choose to do it out here rather than in the dome tonight? So with these objects being due west, being pretty low in the sky, we have got something that is in the way for the observatory, and that's the planetarium standing right there behind us.
Yep.
So we've got the planetarium in the way there. So that is inhibiting our view through there tonight.
By the way, you may be noticing there's a little red flashing battery sign, which means I need to take the camera and replace the battery. So give me just a second. I need to do that. So hang on.
It's all good. Here, I will switch over.
Fletcher will entertain you while I do that.
Yeah, so I wanted to show actually some other images that we had ready tonight. That will help give you an idea of how to view things. This was an idea of what the sky would have looked like a little earlier today. You might see a couple of other interesting points that you can take a look at. The moon straight up above us, as well as to the right of it. If you see a little red star there, that's Mars that you're taking a look at tonight. And then we had some pictures that we took showing, these planets coming closer and closer together over time. So Michelle's been taking pictures for us over the last about, week and a half, seeing them get closer together each night that we had a clear night. So you can see the 19th here, the 20th, moving into the 26th just a few days ago. You can see they're much closer. So that gives you an idea of what you might see with the naked eye looking up in the sky, and see that you'll be able to see them still for a couple more days here. And then one other picture that we had that I think is so great is another one of our colleagues, Andrew Johnston, sent us this picture that he took last night of Venus and Jupiter right beside the Washington Monument. Thought that was a really great picture that I wanted to share with all of you.
Is that the coolest picture or what?
That's a really good one. So really great one to share. So you can see that they change pretty significantly night to night. Tonight they're appearing right next to each other. Even just I believe you took this picture yesterday.
I believe
there was quite a big difference in where they were appearing in the sky.
Yep.
So this is kind of what you would expect them to look like, or about the distance they'd be apart come tomorrow as well. Probably about that same amount of difference.
Yep. So I changed the battery. So there you go.
There we go. Back to the telescope view. No worries. Any last questions in the chat here while we take a look at Venus and Jupiter tonight? Any other questions from anybody?
Hey, let us know. Are you actually seeing this? Are you out in the real world, in the real life, actually looking at the sky and checking this out? We want to know. Because that is ultimately what this is all about, to get you to go outside, not just join us online, which we are more than happy to have you. We would love to know that you are out there actually looking at the sky. If it's clear out where you are, if it's cloudy, well, it's cloudy a lot in the Chicago area. We are amazed that it's actually
We've dealt with
clear.
that a lot, thinking to some of our past shows like the Occultation, didn't get to see much that night. So we're just happy that we get to view this one, view it all with you, and hopefully all of you are able to get a chance to head outside and look at it yourselves, because they're still looking pretty high up in the sky right now. I reckon that's probably about 20 degrees up still, so it should be pretty easy to see from most locations. And a lot of the times if buildings are in the way, streets, especially here in Chicago, line up pretty east-west.
Yep.
So you might still be able to get a view down there on the sidewalk. Should be great.
Folks are asking if we can see the phase of Venus. Let me check to see if I can bring that into view. The planets are getting lower, so we're looking through even more air, which means the view is going to be even fuzzier.
Right.
So it's not going to be great, but we're going to try. So
yeah, we'll take a look and find out. Michelle's going to zoom in a little bit closer on Venus there. Now, I will say that, it's pretty easy to notice the different phases when you're in something like, the crescent phase of Venus. But as it gets larger and larger, Venus is honestly very, very bright, and it can be tough to see some of that detail. Yeah, you can see Michelle really turning down the amount of light that the camera is collecting here.
That is about as...
I'm trying to look there. Yeah, it's I
tough.
think I remember seeing it as about this big when I looked at the phase, about 3/4 full. So it would be tough to spot. Sorry, if you see it where you see us both looking forward, that's where we've got our view of the telescope screen.
A little behind the scenes action here.
It's tough to see. Again,
tough.
just like with Jupiter's bands, I think I can only convince myself knowing that it is there.
Right.
Yeah, that makes a big difference. So tough to tell. It's definitely much easier to spot those different phases when you're looking at it when it's smaller, when it's in its crescent phase, things like that.
Yep.
And on a night where the air is a little less turbulent.
So we've gone back to Jupiter real quick. You can see the moons there.
Yep, back to get a quick view of Jupiter. And actually, this is one of the better views, I think, of the moons and Jupiter at the same time that we've gotten tonight. Yeah, the moon's looking pretty good, and the sky must not be so windy up there in the upper atmosphere now.
And we noticed that there were some wispy clouds here and there that were happening, so that might have been affecting the view.
Yeah, it's been in general real foggy tonight.
Yep.
It's a very humid night, which is it has a big influence on observing. There's so many different weather effects that we look at, beyond just rain. We got to look at clouds, humidity, wind speeds, all kinds of things that affect the perfect observing conditions. Now, a lot of those don't cause such a problem when looking with the naked eye, right? Really the big thing you're worried about then is just the clouds. So fortunately here in Chicago tonight, should have no problems viewing it.
Right. So this has been really super fun.
It has been fun. Yeah, this is a really new setup for us here out on the north terrace of the museum, a different spot than we usually set up in. So it's exciting to bring a unique view for our Sky Observers Hangout. You can tell with the new setup. Whoops, we started a little late today because of some technical difficulties, but hey, I'm glad we could join all of you here today. Thank you for being patient and waiting for us to go live. And make sure to ask your final questions in the chat now if you have any, okay?
Yep. So
before we wrap up here
So
tonight.
we're looking up at the planets right now. If you are wondering what the heck we're looking at, we're checking out the conjunction of Jupiter and Venus in the sky in the Chicago area. If you go outside, you face west, you look up, it's the only two bright things you're going to see because these two objects are very bright and Venus is the brighter one. And so the way we're looking at it facing west, Venus is the one to the right, Jupiter is slightly dimmer, it's the object to the left. And if it's cloudy where you are, don't worry. If you might get a clear sky over the next day or so, the two planets won't be quite as close together, but you'll still see them. Venus, if you're wondering which one is which then, Venus is the brighter one. Jupiter is the slightly dimmer one. Venus is pretty much always going to be brighter than Jupiter. So
yeah, Jupiter's a little further away than Earth right now. It can get brighter than what it is right now, but usually not going to reach the brightness of Venus. Ooh, a question from the chat for our last moments here. A little bit of a throwback to our last Sky Observers Hangout, right? About is the green comet still visible?
Well, if you have a big enough telescope, yes. But if for the rest of us, no.
Yeah, and when we say big enough telescope, we're talking research grade. The biggest telescopes in the world would be able to get a glimpse of it. Still, I'm not sure about from the northern hemisphere. I think it would just be up maybe. I don't. Could we see it from here anymore? I think now it was more visible from the southern hemisphere, right?
South. Yeah.
Yeah, so definitely tough to view. But if you know, now that we aren't able to see it so much in the sky, you could always go back and watch our past Sky Observers Hangout show, see what it looked like through the Dome Observatory, where we were able to get a view of it.
You know what I want to do is one of our very last views. I'm going to throw the camera lens back on this thing, throw it on the tripod real quick, and show our beautiful.
Oh, absolutely. That's a great way to send people.
Hey, got a couple minutes? Hang tight. Hunter's going to entertain you for a second. I got to grab a couple things.
Oh, I'm good at entertaining here, so we'll switch over back to just this view here. She's gonna switch off the telescope view that we've got going tonight and show you the view of the beautiful skyline that we have there, because it is honestly hard to miss. So if you're interested in watching some of those past Sky Observers Hangout shows, things like the Green Comet, or maybe some future shows that we're going to do in the in the coming months, the coming years even. There's so many exciting celestial events happening. Make sure to subscribe to our YouTube channel. Like this video if you enjoyed the content that you're seeing today. Jennifer will also be posting a link to a survey in the chat where you can let us know how you enjoyed the show today. You can even let us know some topics that you think would be fun for us to cover in the future. You can see Michelle's setting her tripod up here, gonna take the camera off of the telescope and now switch it onto the tripod so we can get a view of the beautiful city. Maybe a view of the telescope that we used tonight too. We haven't been able to show you that today. They're right next to each other, so
I can definitely do that. All right. Can you tell we just don't want this fun show to end?
It is tough to deny the people the view of the city that we have here tonight. So we do have some folks down below us here on the sidewalk observing the conjunction as well as the city tonight. We've got some small scopes set up. So great that we've been able to do some in-person and online observing tonight.
So what I'm doing is I'm putting the camera tripod adapter there on the bottom of the camera and putting it on the tripod.
Now, after we close out with our beautiful view of the skyline tonight, we'll also be showing there will be a slide that shows links to some of our social media channels. You can tag us if you're watching tonight. Use the hashtag #lookup. Maybe you could post your views of the conjunction that we had tonight. Let us know. Show us what it looked like from your location, whether it be Chicago or Mexico City, like people were joining from today. Michelle's close to getting that view set up there.
That's cool.
All right, can you see the little one here? Should I switch over to that camera view there? All right. So here's the view looking towards Venus and Jupiter. Sorry, you can't see us right now. You can hear us at least. Here, I'll throw us back in the top corner. So you can see him right there in the middle. Maybe you could point it out.
Yeah, hang on. It's the two dots. Whoops.
There's two little dots there. Yep. Hard to get the city as well as the two planets in focus. So this will give you an idea of what it would look like if you were taking a look with the naked eye tonight. This is pretty close to what they look like for us here from this location right now. Yeah, so you can see them right there, and they're pretty much straight west at this point.
Look at that.
There they are up in the sky. See a few of the buildings of downtown, kind of the southern side of it.
Yep. You want to see the rest of the skyline?
Yeah, let's take a look at the rest of the skyline. Oh, wrong one. Apologies for the bright ring light view there for a second. So there you can see our view of the rest of the skyline that we have tonight. Gosh, just so beautiful, right? I love the view from here at the planetarium.
And if you're wondering about the telescope that we were using, I think I can show that to you.
Right, yeah, maybe a little close. There it is.
There it is. So this is a Takahashi 4-inch refractor, meaning the main lens is 4 inches across. So I'm gonna go back to Jupiter and Venus, because that's what y'all are here for.
Yes, absolutely.
There they are.
All right, there they are. You can see them. Oh, and a little bit of the telescope there over on the right side, peeking out.
Exactly.
So there's our final views of Jupiter and Venus for the night. A little bit different than what we were looking at earlier. Fun seeing the city there below it.
Yep.
Other than that, any final words from you, Michelle?
Go outside, go see this.
Yes, that's a great final word. Let everybody know, hey, this is such an easy one to view. Go and check it out. No matter the light pollution that you have going on, we're right by downtown and they're still super bright and visible. And any day of the rest of the week, these will both be big and beautiful in the sky, even if they're not kissing like they are tonight, right? All right, well, thank you all so much for joining us. We'll leave you with this view for a second. And that's all for us tonight. Thanks so much for joining, everybody.
Good night.